Hello everyone, welcome to the video. Today we are going to solve the problem stock, buy and sell. In this problem, we are given an array and every element of the array represents the cost of a stock on a particular day. For example, the stock costed rupees 100 on first day. On second day, it became 180. On third day, it became 260 and so on. And what we have to return is the list of days on which we should buy and then sell the stock so that we can make the maximum profit. Example, here we should buy on 0th day and sell on 3rd day, and then we should buy on 4th day and then sell it on the 6th day. So we have to solve this problem. We won't directly jump to the solution, but instead we will gradually build and see how to reach the solution. We discuss the questions of data structures and algorithms on this channel in simplest words with fundamental approach. If you are new to this channel, please subscribe. Let's start. To begin with, let us first note down the key things given in the question. We are given an array. Every element of this array represents the cost of stock on a particular day. We have to buy and sell in such a manner that we make the maximum profit, and we can buy and sell any number of times. And what we have to return? We have to return a 2D list of days that represents on which days we will buy and on which days we will sell. So if we see an example, here in this array, we are given the cost of a stock. Like on 0th day, the cost is 100, first day it became 180, second day it became 260 and so on. So the final answer for this array will be 0, 3, meaning we buy on 100 and sell on 310, and 4, 6, meaning we buy on 40 and sell on 695. This combination will give us the maximum profit. We have to note here that there can be multiple answers to this problem. For example, even just this 0, 3 can be represented as 0, 1, 1, 2 and 2, 3. We should also note the format of the output that we have to return. Basically, the output format is a list of lists, and each of these sublists contains only two elements. The first element represents the day on which we buy the stock, and the second element represents the day on which we sell the stock. So if we consider our solution as a black box, we are receiving the array and its size as an input. And what we have to return as output is a list of lists. So what will our function signature look like? It will look like this. Before jumping to the solution, let's first try to visualize the problem. In the example array given, our aim is to make maximum profit. And how will we make the maximum profit? Every time there is an increase in the cost, we should not miss that opportunity and we should book profits. Let's see in this array, how does it look like? First, the cost increases from 100 to 180. We should book this profit. Then it increases from 180 to 260. We should book this profit as well. Then 260 to 310. We should book this as well. Now it comes down to 40. This gap is of no use to us. But from 40, it increases to 535. We should book this as well. And then 535 to 695. We should book this as well. Therefore, if we do not miss any opportunity wherever there is an increase in cost and we book profits on each of those opportunities, we are going to make the maximum profit. So what are the observations that we can make about approaching this problem? We can see that we are definitely going to iterate over this array. And second thing that we can note is that in every iteration, we will be dealing with two things. What is the current stock price and what is the next day's stock price? So let's see how will the algorithm look like. We are definitely going to iterate, and in every iteration we will have today's cost and we will know the next day's cost. We will compare the two, and if the cost on next day is greater than today, then we know that we have to buy today and sell on the next day. So we will add both of these days to our result. Result will be something that we will be maintaining from beginning, and later we will return the result. What will be the time complexity of this solution? It will be just big O of n, since there is only one iteration here. Also, if someone asks that what will be the value of the profit that we make, even that we can do. We can just keep a variable profit here, and whenever this condition is satisfied, we can update the value of that variable profit with the amount of profit that we make, and then return profit as well. Let us now see the working code for the same algorithm that we just discussed. First of all, we declare a result list of lists, which is empty to begin with. Then we iterate over our original array. We iterate till the second last element. And in every iteration, we have the current day's price and we have the next day's price. And if next day's price is greater, that means we have to add this pair of days to our answer. So we declare a new list, we add the 2 days to that list, and then finally we add that list to our result. Then we finally return this result. You can also find the link to this code in the description. To summarize, we first understood the problem with the help of an example. We also saw and understood the output format that we have to return the result in. Then we visualized the problem and we observed that we need to buy and sell every time there is an increase in price. Therefore, we need to iterate and see if the next day price is greater than current day price. If it is, that is part of our result and we have to add that to our result. We built the algorithm for it and we also saw a code walkthrough for the same algorithm. This is it for this video. Please subscribe our YouTube channel and join our Telegram channel. The link for the Telegram channel is also in the description. We will meet again in next video with some other problem. Thanks for watching.